So today lecture outlined are this: introduction to feature engineering techniques, feature extraction, feature importance. So we will discuss all these things in detail, inshallah. Introduction to feature engineering. So what is the feature engineering here? It is the act of extracting features from the raw data and transforming them into the format that are suitable for the machine learning model. As you know that if the data is in the raw form, there will be several things. Some unwanted parameters will be there. Some there will be duplicate parameters. So all these things we cannot give directly to the machine. So we need to extract the important features, and then if we need to transform in other format, we need to do that, and that is called the feature engineering. So we will discuss all these things in detail. So now here, suppose if we are having this plot, okay, so in this plot you can see here it is linear regression, and this is one dimensional plot, and you know that linear regression is nothing that they are using the equation y is equal to mx plus c. So y is equals to mx plus c, you know this equation. And girls, these things, linear regression, we will see in details inshallah after this topic. So we will see all these things in detail, but what are they going to explain here? That if I have these points, these data points, and I am going to make a straight line, so some of the points are lying on that line, some of the points are not lying on the point. But if I want to make here like I want to know that how much is the distance. So here you can see that these are the predicted results, the red one, okay, and the blue one is the observed output. So you can see how much is far from that. So using that, you can see the distance from the predicted and the observed results. So you can see the error using this, that how much is the error do we have. And you know how you will get these all these things. So you need to find out the value of m, means w, and you need to find out the value of b also, which is the constant. I will explain these things later whenever we will discuss in detail the linear regression. So not now. So after calculating, after using these values, then you can place y, and you can vary your one feature, this is x, and definitely you will get different values for all. So based on this, we will make this straight line graph. So here, so it means using that graph, you can understand that the feature is numeric, means the raw data is in numeric form, and if it has a linear relationship between y and x, so then we can plot the linear regression graph like this, okay. And then using that, whenever we will plot, we will see that which point is very far from the predicted, so we can consider as an outlier later, and we can delete, means we will have the idea of our data. Then next, here, multiple input feature. Suppose we don't have a single feature, we have multiple features, then how your result will be. So if we have multiple features, then we will use this equation, okay. And sometimes we don't have the linear, we have polynomial, means we have the graph like this. You can see polynomial means the quadratic equation, means this output y is, you can see here, x1 square, then x2 square. So the relationship is not linear, relationship is quadratic, means which plot you have to make to analyze your data, to extract the feature. Based on the data points, you will check the data, and then you will analyze that it has the linear relationship, or it has quadratic relationship, or which type of relationship it has. Based on that particular model you will use, okay. Now suppose I have these graphs, okay. What do you mean by degree? Degree means here the powers, means power of 2. So if I have polynomial, suppose I have this graph, okay. If I have degree 14, means x raised to power 14. So these number of features you have. So you will get this type of graph. If I have degree 20 means x raised to power 20. So if you have x raised to power 20, so you have several features, and look, data points is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 21. So data is 21 and you are adding 20 more features there. So approximately equal. So that's why the graph touches all the points, right? So we were thinking, wow, we are getting very good graph and all the data points, it's relate to all data point. So but this output is not required, it's not acceptable. Why? Because this type of result will have the issue of overfitting problem. Overfitting problem I explained several times. What will happen in overfitting problem, that whenever you will do the training, it will give you very good percentage 95, because look, everywhere all data points it's connects. But whenever you will do the test, means with new data set, so then with due to too many features, it will be overfitting, and the result for the test data, for the unseen new data, it will be maybe 50% or maybe 65%. So you will not achieve the desired frequency. So that's why this is not the meaning that if you will increase more number of features, you will get very good results. So it is not related to that, right? Another thing here, if you want to compare MSc versus degree, means you can see the error and the degree. So whenever we are increasing the degree, look, the error was reduced. Okay. So error is reducing for the test data, look the same. But after some time, what is happening? You can see that it is increasing, and this is called overfitting, and we don't want the overfitting. Okay. So that's why we can say that if the data is we are adding several features, so we cannot say that we will get a perfect frequency or perfect result. It does not completely depend on the number of features. So we need to take care of these things also. So same thing I am explaining here in this. So if we have this, new features will be x to the power 2, degree 2, degree 3, degree 4, like this. Degree of the polynomial. So degree means d, if large, more flexible model. So it will be more flexible, yes, definitely, because several features you added. But it is not like that you will add many features. So definitely then it will be the overfitting issue. So here, degree 2 will be a smooth curve, capture general trends, good balance, and slightly underfitting. But if I'm talking about degree 14, this is more flexible, fits training data better, and captures more patterns. But if I'm talking about the degree 2, degree 20, so there are several features we are adding, and data points is only 21 and we are adding 20, so it is approximately equal. So we are giving the data result will be like overfit. So what do you mean by model overfitting? Model has too many parameters because we are giving too many parameters. Fits noise instead of real pattern. So due to that noise, you are getting the frequency 95% while training. Perform poorly on the new unseen data. So that is the problem with the overfitting. I hope it's clear to everyone. Now, so this graph shows, which I explained the last graph. Last graph shows the overfitting. Okay, and this is not good. So that's why we can say that it is not mean that we will increase the degree as much as we want. We need to take care of these things, that we should not have the overfitting or underfitting. So if we will have these things, we will not get the desired accuracy. Now, feature engineering techniques. So we are discussing about feature engineering techniques. So first is feature scaling. Now again, the issue that suppose I have a data set, and in that data set, some points are in suppose 100 range, but some of the points are in 1000 range. So 100 and 1000 is a big gap. So that's why this is required scaling. Okay, so we need to do the scaling, because if range of input varies, so in some algorithm object function will not work properly, because there are several algorithms which we will learn. It works based on the distance. So if the algorithms works on distance, and you are using a very varies inputs, means the range is varies, suppose 100 and 1000 range. So based on distance, whatever the algorithm works will not give us good result. So that's why this is very important, that we need to do the scaling, feature scaling. So now I am going to explain what is feature scaling. So here we have these types of techniques. So we need to apply these techniques to make the to do the scaling here. Now, so what we will do for the scaling first is absolute maximum scaling. So absolute maximum scaling, what it does, what are the data sets do you have? So first it will take the absolute value for all, and then choose the maximum. After that, what it will do, the maximum value will be divided by all data points, and then my data points values will lie in between -1 to 1 range. So there will not be too many variation. So here you will not understand. So I am giving you now example. Based on that, you will understand that how it is happening. So now you can see here, I have absolute, this is my data set. This is my data set, and in this data set the maximum value absolute I am getting here 50. So what I will do, I will divide each number with 50 like this. So what the data points I am getting now, this means the values will lie between -1 to +1. And this technique is very sensitive to the outlier. So outlier, why it is very sensitive? Suppose here is one value which is 1000. So if I have a value 1000 in this data point, so what will be your maximum? Your maximum will be 1000. So if your maximum will be 1000, and now all data points you have to divide by 1000, right? So what will you get? You will get minus first point 0.004. The next point you will get minus 0 point, no, 0.04, 0.02, like this. Okay, so now you can see that the values, before I was getting look 0.8, 0.4, but now it is 0.04, 0.02. So this is very sensitive to the outlier. Okay, so that's why if we have outliers, first things we need to handle it. As I explained in the last lecture that how to handle the outlier, there are several techniques we discussed before. So you need to use that technique and you need to try to solve it. Okay, first this issue, and later you can start on the feature, you can start the feature engineering. So if we will have the outlier, most data becomes close to zero, and look, it is close to zero, so which is not good. So model loses useful information. So model will not predict based on this the values which is near to zero. So that's why it is very important point that we need to handle the outlier first. Now next technique is maximum and minimum scaling. So it is not it is maximum scaling. We have this formula for that. Okay, so here x new is equal to x minus x mean. So you need to memorize these formulas. Based on that you will calculate all the values. So here this is my data set. So first I will calculate the x minimum, which is 100. Then I will calculate the x max, this which is 300. And then you will find out the range. Range is x max minus x minimum. After that you are applying the formula for each values, and then you are getting this final scaled values. So now you can see that my all values is scaled from 0 to 1 only. Okay, but again, this technique is also sensitive to outlier, because if we have here 1000, so definitely these values will change and we will get most of the values which is near to the zero, and then it will have we will miss very important data points. So that's why it is very important, even in this technique, need to handle first the outlier. So this technique is also very sensitive to the outlier. Now here feature normalization. Normalization has this formula. Before it was having here minimum. Now this is mean. So if you do these changes, let's see what will happen here. So now again, because that will also have the same effect. So now you can see what we are going to do for normalization. I have the same data set. So if you apply, you will get this results. So these values, normalized values, will be in this range. Okay. So now you can see that we can easily normalize, but again, here, this is again sensitive to the outlier. So you need to handle these things. Now, feature standardization. For standardization, we have this formula x minus x mean and sigma. Okay, so we need to calculate here standard deviation. And how will you calculate the standard deviation here? So here I have shown that how will you calculate. Suppose I have this data set, and in this data set, first we will calculate x minus mean. So mean is 200. After that, I am going to do the square of these things because it is in minus. After that, sum of all, and then divide by number and square root. So what I'm getting 70.71. So if I apply the formula and then I'm getting these values, so final values I'm getting this. So now what are you observing here? The data is centered and scale. Look, it is centered to this point. The values here minus, here positive, here minus, here positive, like this. Values are no longer restricted between 0 and 1. And even here you can also say that it is not sensitive to the outlier, because if there is outlier and we are not able to handle it, so then we can use this type of technique, because it is not very sensitive to the outlier. So this technique we can use in that case. Now we have robust scaling. It has this formula. So we need to calculate IQR. If you remember, I already explained that how will you calculate the IQR in box plot. I explained clearly. So how will you do that, and then how will you find all values? So I'm going to show you here in the next slide. So for the same data set, first I'm going to calculate here x median, which is 200. Then I will calculate Q1. Q1 lower half is this, upper half is this. Then I'm going to calculate here Q1 value and Q3 value. After that, I will calculate IQR, will be Q3 minus Q1. So I'm getting 150. And then this 150 will be divided to other values based on the formula. And again, you can see that what we are getting this data. Okay, it is again scaled. Median becomes 0. Scaling depends on IQR, not full range. So this is less sensitive to outlier. Why it is called robust? Because it does not depend on mean and max. Outliers do not strongly affect median or IQR. So, whenever you will see the comparison of all scaling techniques, you will analyze that based on the outlier, based on our data set, which technique will be good for us. We need to decide, right, for the scaling. Because you know that if you have several data outliers and you are not able to handle it, means this is the condition, like you have limited data sets, you cannot delete, you cannot handle it, so then you can use the techniques which is less sensitive to the outlier. But if you can handle the outlier, you can delete, then don't use the tech. If you are not able to handle, then don't use the techniques which is very sensitive to the outlier. So while you are going to do the feature scaling, you need to take care of these things, that which scaling technique I have to use based on my data set. Okay, so first you need to check the data set, which type of data do you have. Later you can decide that which type of feature scaling technique I can use based on the data set. I hope it's clear to everyone. Now, feature discretization. Feature discretization. So look, here you will surprise, because always I'm telling, like machine for machine learning, we need numeric data. If I have categorical data, I need to convert it numeric. So that machine, because machine learning works on mathematical formulas. So for mathematical formulas, definitely I need numeric data. But what is this discretization? It is converting. So don't be confused while I'm, because I will explain these things later in detail. Converting continuous numeric values into categorical means, using that you are converting numeric value into categorical. And then I was telling you that you need numeric value, so means again you have to do the conversion. Okay, but that conversion will be in a different format. So don't think here that the what I told you, there is a contradiction. No, because sometimes we face this type of things, that we have the continuous numeric data and we want to convert into categorical. But later, definitely, whenever we are preparing the data set for our model, we need to again convert this categorical data into the numeric data based on different encoding techniques, right? So I will explain these things later. So why discretize matters? Helps to improve model performance, transform non-linear into linear, minimize the impact of extreme values, means outliers, prevent overfitting possible with numeric values. So now we will see here how they have to do it. Suppose I have this data set, and in this data set, I have a range, right? You can see. So I have these range 18, 22, 25, 35, 42, 60. So this is continuous value. I have huge amount of data. So what I will do? I want to reduce the noises by grouping them. So what I will do now? I will say, okay, 18 to 25 will be in young range. 26 to 40 will be in adult range, and the above 41 will be in senior range. So what we have done, that we are not going to apply each number separately. We make in the group. So which is the stabilization prediction. So this will stabilize it. Some relationship are not linear. Okay, so we are using this to make it linear. And extreme values means outlier, we can easily handle that one. Suppose a one person has here 120 age, so we can say 120 also in the part of senior. So that means by using the categorical data, we can easily handle the outlier. So that's why they should not be overfitting. So using that technique, this type of technique we can use in decision tree, rule based system, credit scoring, and risk analysis. So now the question is, if I have this, then what we will do here? So we will do encoding techniques. So I will explain these techniques later, that how we will convert this categorical data into the numeric, right? But now I am explaining here for this discretization, which type of method do we have. So we have two types of method for this discretization. So equal width binding and equal frequency binding. It's very easy, it's not difficult. So now let's see one by one each method. So first is here, this is the method, the example is here, equal width binding. So what we are going to do, that in that case, suppose I have this data set. So if I have this data set, so what is my first task? That I will arrange in a order my data points. Whenever I will have this, then I will calculate the W. Everywhere, formulas. So this is very important that you need to memorize the formula here. So W is equal to maximum minus minimum upon N. So what is N? N is the number of bins, and this number of bins you will decide. Means how many sets, how many bins do I need? Suppose I need 5, so I will write N equal 5. Here I am calculating only 4 bins, so I wrote here N equal to 4. So my maximum range is what? 54. My minimum range is what? 10. So what is my W? 54 minus 10 upon 4. So I am getting 11. And using this 11 W value, I will calculate the lower range of bin 1, upper range of bin 1. So how? Lower range is the minimum one. Upper range will be minimum plus W minus 1. Minimum is 10. So first range is 10. Then for second range, I need to put the values 10 plus W is 11. 11 minus 1. So I am getting here 20. So using that, you can see that minimum range is 10 and the maximum range is 20 for bin 1. I hope it's clear. That means in bin 1, I mention that the values will lie from 10 to 20. That means 10 to 20, what are the values here, till here? So these four values will lie in bin 1. Similarly, in bin 2, the values will be 21 to 31. In bin 3, 32 to 42. And in bin 4, 43 to 54. So in such a way, you can make the number of bins. Now, equal frequency binding. Okay, so now we will do here equal frequency, because in the previous one you can see here are 4, here is 1, here are 2, here are 4. So there is not equal frequency. So now we have other case where we can make the equal frequency. How can we do that? First, arrange the data, sort the data. After that, need to decide how many data points and number of bins do you want. So total data is 12 and you want 3 bin. Means you have to divide by 4. So 12 upon 4 is equal to 3. So what will happen? In each bin, we will have 4 data points, equal data points. Before we were not having that case, right? So now we have 4 points here. Then next 4 points will be in next bin and the next points will be in that bin. I hope it's clear to everyone. Now, feature encoding. So why do we need look? As I already explained, that I have now categorical data. So I want for the machine only the numeric data. So how do I convert this categorical data into the numeric data? Using the encoding. So now I am going to explain the encoding. So feature encoding in machine learning, we must transform strings of categorical variables into number so that algorithm can handle those values. Even if you see an algorithm can take into a categorical input, but definitely they are converting the categorical into numeric, because we know that all model works with the formulas, so we need to convert them. So first is one hot encoding. How it is doing? Suppose I have an Audi car, so we are considering 0 value. Volvo, we are considering 1 value. We are assigning some values. Saab, we are assigning 2. So then, so using that criteria, because we did 0, 1, 2 coding, so based on that, we can say the model can easily understand, okay, because here this is the value of 2, means this car is better than others because we are assigning 2, right? Maybe based on that, machine will understand, okay, one, it is better than that Audi. And if suppose there is a value 1.5, then the model will understand, okay, the car is having half property of Volvo and half will be of Saab. So based on these one hot encoding, the model will confuse. Model will not give us very good result in such condition. So you can see here, that's why it's not a good choice, okay, to assign 0 1 2. So what we should do here, we should do in such a way, means if I have a Audi car, so what I am going to do, I am going to use here 1 and the other values will be 0 for other cars. And if I'm talking about Volvo, so then Volvo will be 1 and the others will be 0. So means you can see that I had only one feature, which is car number, and we are converting this one column into how many columns? 1, 2, 3. Means for that car names, we are getting 3 more column. And again, it's a issue. Why? Because if you make like this, the model will be slow because several things it has to analyze it. So means you converted single dimensional into multi-dimensional, and which is difficult to handle the machine. So that's why this is not a good practice to do one hot encoding. If we have a small data, then we can do that. It's fine. But if we have a huge number of data, then again, it will be a too much burden on the machine to do that, right? So that's why we are going to learn other technique also. So this has this issue because create very high dimensional data set and that is very sparse. What is the meaning of sparse? Sparse means most of the data having zeros. Because look, if I have suppose this 1,000 car and I am going to do that. So for 1,000 car, can you see here? 1,999 zeros and there will be only one value will be one. So that is not good practice. So for a small number of data set, we can do that. But if we have huge number of data set, we should not prefer this. Okay. So now we have other technique. So what is the other technique do we have? Now, we are doing label encoding. So, what is label encoding? So, label encoding, we need to assign the labels. Means we are saying, okay, 0 is for Audi. Okay, but as I already told you that if we are going to design 0 1 2 label encoding, then model will understand, okay, 1 is less, 2 is more, right? Means the car which is Saab, it is better than Volvo, and Volvo is better than Audi, like this, but which is not true. Okay, so means label encoding is also not good, but we cannot say the label encoding is always bad. No, in some cases the label encoding is also good. In which cases? Look, I mention here. So we cannot say the label encoding is always bad. No, in something it can be good. If I have the data, because you need to analyze the data set, which data do you have? If I have the data, suppose this type of data has some order, means ordinal data set. I have low, medium, high, suppose the customer satisfaction we are asking. So how so then in that case we can use label encoding. If I'm using like education, high school degree, bachelor or master degree, like some survey, then we can do here also label encoding, because it is the data set is in order. So for order we can do label encoding, there is no issue in that. If we have tree based model, so decision tree, random forest, XGBoot, they split by threshold and they don't assume linear distances. So even label encoding is good for them also. So label encoding is not always bad. It is bad only when the numeric order does not make sense with the model being used. Means if your data is ordinal, so then you can use this. There is no issue at all. It will give you good result. But if your data set is not ordinal, then don't, it is not prescribed to use this technique. So now the question is, okay, then if we don't have ordinal data, then which type of technique can we use? So now the next technique, which is called target encoding. So in that case, you can use the target encoding. Okay. So what is target encoding? What is target encoding? Another popular method, which is target encoding. The target variable is what you are trying to predict. This should be a numeric value. So you might have to do a value encoding on the target variable. For example, say yes or no on the previous slide. So now I will explain in detail this target encoding. So here I have the same data set. So for target encoding, what will you do? Suppose I have Audi car. So how many times do we have Audi? We have two times. And both times it is no and it is no. Means Audi has two occurrence and both occurrence the result is zero. So that's why the output is zero. Means we assign the Audi car value is zero wherever we have Audi zero. Now, if I'm talking about Volvo, then you can see it has one, two, three occurrence. And out of these three, two times it's yes and one time is no. So means it has 2 upon 3. So 0.67. So wherever we have this Volvo car, we will replace by this number. So this is called target encoding. And it's very useful, target encoding. So target encoding will be like this. Now, target encoding advantages. It does not give you high dimensional training set because this was the issue right before. Target encoding allows numeric relationship to be learned between the categorical values and the target values. So these are the advantage of target encoding. So now the next. Why feature transformation is required? Now the transformation. So we have done scaling, we learned the techniques, we have seen the encoding techniques. So now feature transformation. Why do we need the transformation required? So many machine learning model assume a linear relationship. So suppose if the relationship is not linear and you are using the model which is using linear relationship, suppose, so then the model will perform very poor. So that's why transformation is required based on the model requirements. So you need to transform, suppose the model which you want to use is using linear relationship, but you are giving their polynomial data set, so then it will not give you good result. You need to transform. Okay, so how will you do that? Transform matters because linear regression is a straight line, so we will have this type of relationship, this type of this, right? So in that relationship, this is a straight line, right? But suppose you are giving the model which does not need that. So that's why it will give you not good results. So you need to analyze, you need to sometimes transform. So what is the beta 0 here? Intercept. Beta 1, B2 are the weights, how important each feature is, and X1, X2 are the features here. So now you can see, look, with this example, suppose I have the student data that I want to predict that the student will pass or how much it will score in the exam. So suppose based on study hours, I want to decide this. So I am going to taking study hours and the exam score. If the relationship is curved, suppose because it is variation, means it is studying 4 hours, okay, and then he is getting 16 marks. Okay. Suppose somebody is studying like 5 hours and getting the 25 marks like this, huh? So if the relationship is curved, can you see? This is not linear, this is curved. So linear regression model you are using, it will not fit. So then we can use x square polynomial. We can use log x, square root of x. Now the model can fit better. So you need to analyze the data. You need to understand the data, that which type of data do we have. Based on that, you will decide that which model you can use. I hope it's clear to everyone. Feature transformation. Now next, second one, linear assumption on logistic regression. So we have logistic regression also. Logistic regression is used for classification. It will give you the result like somebody will fail or pass or spam email or not spam email. So logistic regression does not assume linear relationship between feature. It assumes linear relationship between feature and log odds. So now the new term, log odds. So what is this log odds? Log odds is not probability. It is, you need to calculate the log odds. So here, what is odds? P upon 1 minus P, where P is the probability, right? So what will be the formula for that? It will be log P over 1 minus P equal to this equation. So the log of odds is linear with x and not directly to the probability. So I can also calculate these values. Suppose I have p equal 0.8. So 0.8 upon 1 minus 0.8. So I am getting 0.2 means I am getting the answer 4. So what do you mean by 4? The meaning is that the event is 4 times more likely to happen than not happen. So this will give you the probability that how many times that particular event will happen. Same. So this is called feature transformation. Using that we can transform. Okay. Why it is important? I already explained. Sometimes we have linear relationship and we are using a model which does not need linear. So then again it will not give us good result. Sometimes we have polynomial relationship, okay, and we are using linear model, so definitely it will not give us good result. So we need to understand, and based on that we have to use the model which is for the linear relationship, which is for the polynomial relationship. So we need to analyze the data, and based on that you will select the model. Now next, summary of feature transformation method means how will you transform. So these are the method. Using these method you can transform the features. Okay, so logarithmic, reciprocal, square root. So it's very easy. So now I will explain one by one all methods. Log transformation. What do you mean by log transformation? You are going to use this type of transformation if you have the data which is skewed to the right side. Means if your data is skewed to the right side, then you will use this type of log transformation. Suppose your data is like this, skewed to the right side, means very small values to the right side. So then this type of data, if you want to transform, you can use here log transformation technique. What log transformation technique does? Suppose I have this data set 10, 100,000, and now using log, it will, you will do the log, and then you are getting the value 2.3, 4.6, 6.9. Look, before the range was wide, can you see? But after this it is shrink and data becomes more flexible, more balanced. So this is the use of the feature transformation. So there are several techniques we need to use here. We have other technique now, reciprocal. What is reciprocal? Means 1 upon something. So I have this data 1, 2, 4, 10. I will take here 1 upon 1. So 1. 1 upon 2, 0.5. 1 upon 4.25, 1 upon 10.1. So I am taking the reciprocal, and now my data points is, look, it is transformed. Square root means I need to take the square root of all. So I have the data original 1, 4, 9, 16. After taking square, I'm getting this. Okay. Exponential, we can use the powers also for the curve shape relationship if there. So we can take the exponential also. So these type of transformation we can use if we want to transform the data from one to the. Now the next is box transformation, box costs. It has this formula. And girls, for this transformation, you need to memorize this formula because it is not easily to find out this lambda value manually. Why? Because for all data points, suppose I have these data points, right? So the machine here we using for this Python skippy stats box, we have predefined library for this. So whenever we will use this, means what will happen, this library in Python, they use different values of lambda. They will use here lambda equal to 0, lambda equal to 1, lambda equal to 3, lambda equal to different values, and until they are not getting the values which is best fit. Okay, so that's why we cannot do it manually. The algorithm tries many lambda values and computes likelihood of normality. Choose lambda that best makes data normal. So this is the technique which we cannot do manually. Okay, so we have to do from, you can use whenever you will work on that feature engineering, you can try to do that predefined library, and then you will see how it will calculate the maximum, the best value for lambda. Feature extraction. Feature extraction in machine learning is the process of transforming raw data into numeric feature that better represent the understanding problem to the predicted model. Okay, so we need to extract the best feature. Okay, so what is the meaning of this? Suppose, as the word continues to be embroiled of the AI, and raw data is really useful in original form, but suppose trying to understand a foreign language without a translator, that's what data feels like to a machine. But whenever we are extracting the feature in machine learning, so it is like we are using translator, which is converting raw input to the digestible pattern, and the machine can easily work with that. So this is very important to do the feature engineering. So now I will give you the example, a small example, so you will understand why do we need this. So suppose we have a small data set of house where we have size of whole and the bedroom and the price. So if we extract a meaningful feature, how can we extract? So size and bedrooms are the feature. This is the input and this is the output. We want to predict the price. So what we can extract the new feature? Price per square feet, size per bedroom. So we can do that. Based on that feature, we can extract the, which is very useful feature, because we will just check the size of a square feet, and then based on that we can predict the price. Size per bedroom means per bedroom how much is the size for that. So based on that we can extract the feature. I hope it's clear. Now, Types of feature extraction in machine learning. So we have text feature extraction. These are the types for that. So the first example here, bag of word. How it is extracting the feature. Count how many times each word appear and ignore grammar and word order. Suppose I have this sentence. I love AI. I love ML. So what is the vocabulary here? I love AI and ML. So four things, right? So what is the vector form here? If I am talking about the first sentence, so it will be 1110. In the second sentence, I don't want AI, I want only ML. I love ML. So 1101. In such a way, you can extract the feature in machine learning. Okay. So here different types of techniques are there to extract. Suppose I have images. So then we have this type of technique, HOG, SIFT, deep CNN. And in is what we are doing here in SIFT, we are going to work with the images which is zoom in or zoom out, and we can extract the feature which is hidden. So it is used to detect and describe important key points in images. We use in facial recognition, medical imaging, like this. Next type of other features here, audio feature extraction, and we are doing every day, Alexa, Google Assistants, we are using. Okay. Audio feature extraction. Tabular feature means in the form of table. We have the table, right? And then we are checking. It can be polynomial feature or other. Time series feature. Time series means here, instead of looking at values over time, it looks the cycle. It detects daily pattern. Technique, Fourier transform, lag features. It is the using in stock market forecasting, sensor data analysis, means the complete pattern it observe. That in the morning, that particular thing is too, there were two rush, right? In stock market, or you can say like in the morning the prices were too high, and slowly gradually whenever they pass, the price is going to be low. So it is considering on daily repeating patterns, so that is called time series based on the time. Now feature importance, why it is so important. In machine learning, feature importance scores are used to determine the relative importance of each feature, because there are several features. So, how do we know that which feature is important for us and which feature is not important? So, we will have some score. So, we can calculate the score of each feature, and based on that, we can decide okay, this feature we can keep it and this feature we can delete. As I have given you the example, even I can take the example of this. Look, suppose we want to predict house price. So we want to predict the house price based on size, definitely, how many bedrooms, distance to city. So what we are going to do? We are checking how much score for each. So we will use the techniques and then we will do the scoring. Suppose size. So prices based on size, it is depend on 60%. And based on distance, it depends on 30%. Based on bedroom, it depends on 10%. Means you can see that which feature is more important, you can keep it. Which feature is not having high score, you can delete. So means bedroom, here we can delete that one. So based on the score analysis, you can decide that which feature you want to keep and which you want to delete. Here we information measure, you can also measure using entropy. Okay. So this is the formula for gain. And now I will explain you in detail that how will you calculate this information measure, information gain. So let me explain you. Yes, here. So I'm going to explain now here entropy. And what is entropy here? Actually, it was difficult to write all these things, points in the slide, but then will be too many slides. So I added here in the Word file. I will share with you these also. Okay. So what is entropy? Entropy is the measure of uncertainty or impurity in a data set. It is commonly used in decision tree to determine how fixed the classes are. So this is the entropy formula. Okay. So what is PCI? Probability of class I log 2 logarithmic base 2. The negative sign ensure that the entropy will be positive. So these are the example data sets. Suppose I'm taking it is the same example which is in the slide, but in detail here. So data set contains 4 sample. First sample is 2 yes and 2 no. So step by entropy we will calculate. So before split, we are saying probability of yes 2 upon 4, probability of no 2 upon 4. So put these values here. So what you are getting? You are getting the value -1. Okay. And then if you calculate complete, the final answer is 1. You are getting. Okay. So result entropy before split is 1. This is the maximum uncertainty because classes are evenly mixed. Now, entropy after split. So now we are splitting the feature. Okay. What was the feature? Yes and no. So what is the first subset? 2 yes, 0 no. 0 yes, 2 no, another. So I am calculating the entropy of subset 1, which is 0. I am calculating the entropy for subset 2, which is also 0. So now I am calculating the weighing entropy after split. I am getting here 0. So now I am going to calculate the gain calculation information, IGA. It will be the entropy before and entropy after splitting. It will be 1 minus 0 equal to 1. So what is the final interpretation? Feature A perfectly separate the classes. It reduces uncertainty from 1 to 0. Therefore, it is very highly important feature. So you can keep it with you, right? Because you converted from 1 to 0, from high uncertainty to 0. Okay. So therefore it is highly important feature. So in this way you can decide that which feature are important. Now here they added the distance measures formulas because in several model you will use these formulas, so all in one slide. Here they uses the formulas to calculate the accuracy, the performance, because we need to measure the performance also of our model. So using these formulas we can calculate the accuracy of our model. Whenever we will, because here it is confusion matrix, so whenever I will explain the regression classification, so then definitely we will I will explain how will you use these formulas. So here they added in this slide just to cover that these are the formulas for accuracy. Later we will use inshallah in the model. Now feature selection techniques. So feature selection techniques are these. Feature selection. Feature selection is the process of selecting a subset of relevant feature for use in machine learning model. Building using some criteria as explored in the previous slide. We have seen already. So if we want to select that this is the important feature and we want to select, if it is, we want to delete some feature. So based on the score, we can decide that this is good and this is bad, as we have seen before also. So feature selection. Here, simplification of model to make them easier to interpret, shorter training time, lesser cost in data collection, avoid the curse of dimensionality, means you don't have extra feature which is not required. As I have given you several times the example, suppose I want to predict the salary of a person based on their experience, based on their education, and based on their person blood group. So blood group is related to that salary of a person? No. So that is called the unnecessary features, means there is unnecessary burden on the machine. So that's why we need to check the score. Based on that, we can decide that which one is good feature, which one is not a good feature. So we will use the first method. First method is called filter method. So what filter method, common filter technique are these? These are the filter technique method. And what we do in filter method, we did here this in filter. So in filter method, what we are going to do? First, we are selecting the features here. After that, first we are selecting the features, and then here we will measure score. Okay. Suppose if we are satisfied, yes, then we will go to the learning algorithm, then testing, and then we will get. But if I am not satisfied that this feature, so again this loop will. Okay, so you will be here. So based on that, you will do the filtering of the feature. Next, wrappers method. Wrapper method means there are two types of wrapper method, forward and backward. So even here, I cannot, here, what is the, here wrapper method? It is featured as, so what we are going to do in, instead of guessing which feature are important, we are making subset. Train a model. We will check the accuracy, try another subset, compare result, choose the best subset. So what we are going to do in wrapper method, forward and backward. Possible subset is we can make age, we can make income, we can make education. Now I am going to make age and income, age and education, like this, like this. After that, each subset we will train the model. Measure the accuracy for all, then keep best one. But because we are having several subset and I'm going to apply the train the model for all, so it is, first thing, it is time consuming, and the second thing is it is taking too many, space is required, definitely too much burden on the machine also. But the result will be really good. Why? Because you are checking each combination, and then you are deciding which is giving you the best accuracy. So that is called the wrapper method. Okay, so now I will explain you the wrapper method. How many types? Flowchart. For wrapper method, we have a flowchart here. Feature selection first, learning algorithm we will use. After the learning algorithm, if you are satisfied, then it's fine. If not, then again you will apply another learning algorithm. You will check all these things, accuracy and everything. If you are satisfied, then you can move on. Okay, you will select the best one. So these are two approaches for the wrapper method, forward and backward. So forward and backward, here it's written, but it will not give you the complete idea. So I added here in the Word file. Let me show you that Word file, wrapper method, in the same Word file. Okay. So complete explanation of wrapper method. So what we are going to do? Forward. In forward, what we are going to do here, look. Start with an empty model. Means we don't consider any feature at the beginning. Train separate model using feature individual. Select the feature which gives us best performance. Add the remaining feature one by one. Keep the feature that improve performance most. Repeat until no significance. So now with the example, it will be clear to you. Suppose I have predict loan approval. So I am considering the age of a person, income, education. So here we have three features. Okay. Test each feature individually. So we tested all feature individually. After that, Select income, best performance. So I choose the best performance is income. Then I will make the combination income with age, income with education. Then which one is giving good? Income and age. So I can say, okay, this is the good combination. So this is called forward. I didn't select at the beginning which feature I'm going to, which combination. No, I will work on all. Okay. Then what is the backward? Backward means we will have all available features we will select and then remove one by one. So start with all features. So we have trained with all features 91% accuracy. After that, remove one feature at a time. We remove age, it is 89. We remove income, 70. We remove education, 90%. So we understood, okay. So remove education, smallest performance drop. So we remove this. Now test removing one more feature. So remove age, remove income. We are getting this. So like this. So means keep age and income as final subset. So based on that, we will understand that which feature is giving us very good result, so we need to keep, and which result is not giving us that good result, we need to delete. So based on that, forward and backward you can select. It is called wrapper method, because wrapper method means it's wrap around the model all the time, because you are training the model, you are training the model all the time. So that is called the wrapper method. Real world practical workflow. This is the real world. Data cleaning, data transformation. We have done already. So these are the iterative process of feature engineering. That's it. In class activity, you can do that. Explain feature, data cleaning, feature engineering techniques, all these things. These are the online resources. And these are the things I added extra here. How will you get polynomial regression? How will you get the linear regression? This is the example here. Simple.